All right, let's switch gears here a little bit and look at some ways that we can use this information in practical ways. The first one that we want to look at is what's known as percent composition. It is sometimes useful in chemistry to know what percentage of a compound is, by mass, is in the compound. For example, we sometimes use certain compounds to generate oxygen. It would be nice to know what percentage of that compound is oxygen before we start. And so that's the type of thing that we would use this for. And it's, you can see the way that we started setting things up is what we're actually going to do for doing these problems. Suppose we want to know, if I just ask you what is the percent composition of aluminum nitrate, what I'm asking is what percentage is aluminum, what percentage is nitrogen, and what percentage is oxygen. And so I'm going to set this up just like we did before. And I'm basically just copying what we had here. I'm going to move it over a little bit so I can have enough room to do everything that we need to do. But if you, and this is why I had you set this up in this manner before, because we can work right across the page to get all the things done that we need to have done. Okay, so we have 53.96308, 42.0201, and 143.995. We add those up and we get 239.978. Now, what percentage of that compound is aluminum? Well, right here, this number right here gives me the total amount, the total mass of the aluminum. So if I simply take that, this number right here, 53.96308, and divide that by 239, by the total mass, 0.978, and then of course multiply by 100, that will give me the percentage of aluminum. And when I do that, I get 22.4867. We always want to write, don't just end with percent, but tell me percentage of what? Percent aluminum. I'll do the same thing with the other two, 42.0201 divided by 239.978 times 100, and we come up with 17.5100% nitrogen, and then 143.995 over 239.978 times 100 gives me 60.0033, and yeah, we're good on sig figs there. 6 sig figs in all of those. So that's percent oxygen. Now, when you do these problems, you have one very nice method of checking your work, and that is add this column up. The percentages of all of those should be 100%. Now, sometimes you may find that it's not exactly 100%, but you should not be off by more than 1 in the last digit. Now, if we look here, I think this one works out, yeah, this one works out exactly correct. We get exactly 100%. That tells you you've done your work right. If you come off, if we had 99.999 and we're off by 1 or 2 here, it's probably okay. Sometimes as you do your rounding here, you may get off 1 or 2 in this last digit, but it should never be more than that. If you're anything more than that, I'd go back and check your work. Make sure that you've done everything right. Okay? Let's take a look at another example. Let's do an ionic compound, copper sulfate pentahydrate. Okay? And what this is, we would write this out CuSO4, copper sulfate, 5H2O. What this indicates is that for every unit, for every formula unit of copper sulfate, 5 water molecules are incorporated with that. And this happens when the copper sulfate crystal forms from a water solution. It just traps 5 water molecules in there, and it's always 5, so it's always the same amount. And these can actually be driven off by heating the copper sulfate. You'll be doing a lab like that soon. But this is known as the water of crystallization. The water of crystallization, and copper sulfate is not the only substance that does this. Many, I shouldn't say many, a few ionic substances will incorporate water into their crystal structures and form a hydrate. This, you can drive the water off, as I said, with heating and form anhydrous copper sulfate, and they're very different. Copper sulfate pentahydrate, this one, actually is a very deep blue crystal. When you drive off the water, it forms a white, almost a powdery substance. So they have very different appearances. We're going to set this up the same way we did before. We're going to use list each of our elements here. And I'm just going to write the H2O here. And we're going to try to answer the question, what is the percent composition of water in copper sulfate pentahydrate? So what percent by mass of the copper sulfate pentahydrate is water? So we really only need the percentage of this one. If we look at the formula, we have 1 copper, 1 sulfur, 4 hydrogens, and 5 waters. Now, normally we would not do water like this. However, it is useful to know that the formula mass of water is 18.0153. That's a number you might want to write down and have somewhere where you can access it readily, because you'll run into that frequently from here through the rest of the school year. And so it's just a handy number to have. Write it down somewhere where you can very quickly access it. If you have a paper book cover, maybe write it on that book cover somewhere. Don't write it on your book, but someplace where you can easily find it. Okay? Now we'll also get the rest of these. Whoops, that's times. Copper is 63.546. Sulfur is 32.065. And oxygen is 15.9994. And so if we do this, we multiply these out, we come up with 63.546, 32.065. This one comes out to 63.9976, and the water comes out to 90.0765. When we add those all up together, we come up with 249.685. And I've already taken sig figs into account here, so we're dealing with that. Now, to calculate the percentage of water, all we have to do is take the 90.0765 divided by 249.685 times 100, and we come up with 36.0761% H2O. Now you'll notice that if I don't have to answer these others, if I don't need to calculate the other percentages, I don't really have a way of checking that answer. I'm fairly sure that one is correct, but it might be worth your while, at least starting out, to go ahead and calculate these others and add them up and just make sure you come up with 100% so that you're certain that you're doing those right. That's just a quick way of checking. Okay, well that concludes our session here for today. I hope you've learned something. If you have any questions about any of this, bring them to class next time you have class, tomorrow or the following day. Thank you. Bye.